Hey all, welcome back to one more session today. So in today's session we are going to talk about one of the important concept in system Verilog, which is OOPS properties. So there are four main OOPS properties in system Verilog which are most frequently asked in any interviews that you go. Okay, so these are the four OOPS properties that we are going to talk today. That is inheritance, abstraction, polymorphism, and then encapsulation. So the thing here is I have actually done a video on these four properties in detail with examples. Okay, I'll link those all the videos in this description box. You can go and check them out if you are interested. But the main motto of doing this video today is that many of you are requesting me to give me a detailed definition on all these properties. Okay, so in order to give you a detailed definition on these properties and in order to make you understand clearly actually what is the this property stands for, what is the meaning of this property, and where do we actually work it. Okay, so in order to make you clear on all these things, I am going to make this today video in order to explain all these properties in one go. Okay, so let's not waste any more time. And before entering into this video, if you are new to this channel, consider subscribing the channel and hit on the notification bell also. Also, please share this video to any VLSA aspirant who want to enter into design and verification domain. Okay, now coming to the first property, which is inheritance. So inheritance is nothing but we are going to create a new class based on the existing class. That is basically everyone say it as an inheritance. Okay, and this inheritance property is having many benefits, like you can reuse the same code, because here what you are doing, you are actually using the same code in order to build another new code. So that is why you can reuse the code, you can create new classes based on the existing classes, and then it will be specifying new implementation. Okay, now let me give you a small example in order to understand about this inheritance clearly. Okay, let us consider we are talking. Okay, now let us take one example, like we are designing. Okay, we are taking the data of some vehicles. Okay, we are talking about vehicles now. So coming to vehicles, any vehicle, because we are having various categories in vehicles, is it or not? We'll have bikes, cars, okay, tractors, right? Like many other vehicles. Okay, so if you see here, every of these vehicles will be having some properties in common. For example, every vehicle will be having brakes, right? Every vehicle will be having tires, right? Every vehicle will be having lights like headlights. Okay, so in this way, all these vehicles, when you're talking about vehicles, these vehicles will be having some properties in common, right? And then coming to the categories, subcategories of the vehicles. So this vehicle is nothing but parent class. Okay, I'm just relating this to the inheritance. So when we are talking about vehicles, nothing but we are talking about parent class. So similarly, this parent class will be having some properties and methods. Okay, just like vehicles are having certain properties like brake, tires, everything. In this way, the parent class will be having properties and methods. Similarly, coming to the subcategories in vehicles like bike, car, tractor, so these are nothing but our child classes. Okay, so this is the existing class. These are the new classes that are taken from this existing class. Why we are calling it as we are taking that? Because when we are talking about vehicles, these are sub things like subcategories: bike, car, tractor. If you see here, every subcategory will be having all these things, is it or not? Bike will be having brake, tires, right? So everything in this way, every headlights, everything, all the vehicles will be having these properties in common. But along with these properties, if you are taking bike as example, it will be having only two tires, is it or not? Right? And it will be having only gears. Okay, only gears, accelerators. Okay, these are some common, and it will be having some two tires, right? And now when it comes to the car, okay, so when you are talking about car, along with these properties, the bike is having its individual properties. Similarly, when we are talking about car, it will be having four tires, it will be having some GPS tracker systems inside the thing. So in this way, the car is having more properties compared to that of bike. So this bike is having its own characteristics. Similarly, car will be having its own properties. Similarly, tractor will be having its own properties. So just like this, vehicles having the properties, all these vehicles will be having these properties in common. Along with these properties, it will be having these the remaining properties which are only individual to them. Okay, it is only limited to car, because bike can't have four tires, it is limited to car. Similarly, if you are talking about some lorry, it will be having six tires, so it is limited to only that particular vehicle. So in this way, when we are talking about classes in inheritance, okay, the parent class will be having properties and methods. So these properties and methods are common in all these child classes. That means every child class will be sharing these properties and methods of parent class commonly. So along with these properties and methods of parent class, the child class can also have its own properties and methods. Okay, clear? So that is inheritance. Hope you got an idea on what is inheritance by this example. If you still didn't understand, please don't hesitate to ask me any doubts. You can ping me in the comment box or any of my social media handles. Right? Hope you got an idea on what is inheritance. Now coming to the next property, which is abstraction. Okay, so this is one of the property for which I was asked many times, like I have got many doubts in this particular abstraction property. Okay, so coming to abstraction property, basically when anyone asks you like what is abstraction, everyone will say that by using abstraction method we can only extend, okay, we can only extend the class but we can't instantiate it. That is the actual definition. Because if you see in any of the websites or in any of the notebooks also, you will get this one definition. That means an abstract class, which we also call as virtual class. Abstract or virtual, both are same. Okay, actually, abstract is the definition, virtual is the keyword which we use in the system Verilog. So, an abstract class or a virtual class is designed to be extended and it cannot be instantiated. Okay, this is very easy to define in this way. But when it comes to the real time, like when you want a real time example, like where you actually use it, like what is the need of this particular abstraction. Okay, now we are going to talk about it. So these are some of the uses for this abstraction, like we are having a common layout and we will be having the limited data, we'll be limiting the data with the help of this abstraction property, and we'll have model relationships serves as a base class. So all these things, right? Now let me put it with a small example for you so that it will be easily understood for you. For example, let us consider we are taking data of the student. Okay, when it comes to taking the student as an example, okay, students data. Okay, let us consider the students data as an example. Now coming to students data, what are the categories that you can expect from the student data? Like his name, yes, roll number, anything else, like his address, right, his grades, in which grade he's studying or else like that, and his examination marks, his results, right, and anything. Yeah, so these are the things basically. Okay, you can consider still there are a lot more, like his parents um, data, right, and his blood group, everything, right. So basically when it comes to students data, you will have a lot of things. Okay, so this is the actual This is where the actual abstraction property works. What is it means? Okay, for example, if you are taking the class, base class, okay, or parent class, anything. So just like the students data consists of these many properties, this much data in it, similarly the base class can have many number of properties or methods within it. Okay, just like the students data having many data in many categories in it, so similarly the base class is having many properties and methods within it. Now when you are taking the same students data for a library, okay, when a librarian is taking the students data, will he consider all these things? No, right? Because a librarian, what does he basically need? He need the name of the student, or basically his roll number, and if which class he belongs to, and then how many books he has taken, like how many books he has borrowed, and how many books he has returned. Is it or not? So this is the basic thing necessary for the librarian. Okay, similarly when he went to some sports person, when he went to some sports leader or some thing, or pt teacher, okay, when you go to that person, what he needs? He needs the name and roll number, and then class, and then about his height, his weight, his like blood group, everything. Is it or not? So just like, if different, even though the person is same, here the data that is required by these two persons is different. Is it or not? Similarly, in base class, even though it consists of many properties and methods, but the child class which is abstracting the properties, because from inheritance you know that every property of the base class will be belonging to its child class. Is it or not? So in such cases, all the child class may not need all the properties and belongings of the parent class. Okay, just like the librarian don't need this his height, his blood group and everything, similarly the sports person doesn't need how many books he has borrowed or how many books he has written. Similarly every child class may not need all the properties and methods of the base class. Then in such cases, okay, what we will do, we are going to hide the properties, like we are going to hide height, weight and blood group for the librarian, and similarly we are going to hide this borrowed and written properties for the sportsman. How are we going to do it? We are going to do it by using the keyword named virtual. Okay, so the use of the virtual keyword and everything I have already given that in the particular abstraction video itself. You can go there and check it out. So basically this is where you use abstraction in order to hide, because base class consists of lots of properties and methods. So based on the usage of child class, okay, it will be taking the properties that it needed from the base class, and the remaining property it is going to hide. How it is going to hide? It is going to use the virtual keyword in order to ignore all the remaining properties, right? So this is called as abstraction. Now I hope you got an idea clearly about what is abstraction. If you still didn't get it, I also told you for the before one also, you don't hesitate to ask me. You can comment me in the ping box, right? Now coming to the third property, which is polymorphism. So when anyone asks you about what is the definition of polymorphism, what is it? Basically any object or base class object taking many forms is called polymorphism. Okay, so what is this many forms? What is this object? Okay, so now before going into what is polymorphism, when it comes to any property, like all properties in OOPS are mainly for reusability purposes, and it also for reducing code length to make the code look more feasible to while you are reading. So all these things, every property will be contributing its own thing in order to make the code look easier, in order to make the code for reusability purposes, to reduce the code length. So all these things. Okay, so now coming to polymorphism, it is used for reducing the code length and then reusability, right? Here the main thing in polymorphism is the same code will be behaving differently depending on the type of object it is working with, right? We are going to talk about this thing now. Okay, since we are explaining everything by example, let us consider one more example here for polymorphism. Okay, when we are talking about polymorphism. Okay, okay, now let us take one more example. Let us consider, we are considering, we are doing a method in order to find area. Okay, you already know, while you have studied about while your child you studied about calculating the areas, right? Area of circle, area of square, area of rectangle, triangle, is it or not? So my main motto today is to calculate the area. Okay, so I didn't tell any figure, like I didn't give any you have to calculate the area of this particular thing, but I want to calculate the area. So in this area, for example, if you are given only one input, okay, that means I have given only one input A, then with that single output, which area you could calculate? You could calculate the square, is it or not? Since the definition for area of square is A square, so that is why with one input you could calculate the area of square. Okay, in the similarly, if you are given two inputs, then you could go for rectangle because it is 2AB, right? Similarly, if you are given three inputs, then you can go for triangle, is it or not? ABC. Similarly, depending upon the inputs you are given, you are calculating the rectangle, square and triangle figures, is it or not? Similarly, in polymorphism, for example, this is my base class. Okay, so what is my base class here? My base class is area. For all these three things, I am calculating the area itself, is it or not? But depending upon the inputs you are taking, you are calculating which area you want. Okay, that is what, because here the base class is nothing but area. Base class is what, depending upon the child classes you are inheriting, this base class will be taking those many forms. If you are taking three child classes, then this base class is converted into three objects. Okay, so depending upon how many classes you are inheriting or how many properties that you are using for that child classes, so it will be converted into those many forms. That is what I told here. See, even though the same code we are using, here the same base class you are using for the three child classes, even though the base class is same, but it is categorized into three different like three different forms. Similarly, even though the area concept is same here, but depending upon the inputs you are taken, it is converted into square, rectangle or triangle. Okay, hope you got an idea on what is this particular polymorphism. So a single base class is converted into many forms, like it is we are taking many objects for the base class depending upon the child classes we are taking. Okay, so this is about polymorphism. Okay, and then coming to the last property, which is encapsulation. Okay, encapsulation is nothing but, here we are restricting the usage of the components in the particular classes or particular base class or anything. Okay, so now why we are doing it? Okay, so let us talk from the top, like, because in inheritance, okay, inheritance is giving you a advantage to use all the properties of parent class for its child class, is it or not? So by using inheritance property, every child class can handle the parent class properties, is it or not? Okay, now we have reduced it. By using abstraction, we have limited it, is it or not? So by abstraction, we can take only the needed properties for the child class and we can ignore the remaining properties. Okay, and then coming to polymorphism. So in polymorphism, what we are doing, even though the parent is one only, because in any in OOPS concept the parent will be only one. Even though you are having child classes or sub child classes also, the parent is the single class, that is the base class. Okay, now what happens, since this parent is only one class, since we can't share the single parent for all the classes, now what this parent is doing, it is taking many forms. Okay, by using polymorphism, since it can't handle all the child classes, at by using only one parent class we can't handle all the child classes, because that is the reason. Now what is happening here, the parent is taking many forms. Okay, that is polymorphism. And now because of all these things, because child class can handle the parent class can handle the child class, so with one handle you can handle this class, with this handle we can handle this class. Now everything is interconnected here. So among all these interconnections, okay, there may be so many disadvantages along with advantages. Now coming to what are the things, what are the disadvantages. For example, as you all know that parent class, any class will be containing so many properties and methods. Okay, so among all these properties and methods, there may be some properties which you want them to remain in that way itself. You don't want to have any changes among those properties, or you don't want to change any want to have any changes among those methods, because here, since everything is interlinked, if there is one change in that particular property, it might affect the remaining code of that particular logic. So which is why you don't want certain properties in your code to be changed. That means you want them to be untouched. Okay, so in such cases, what you are going to do, you are going to protect them, is it or not? If you don't want to touch it, for example, if someone, if you think that if you are having some property which you think it is very valuable, what you will do, you are going to protect it, is it or not? Similarly, how you are going to protect it in your particular program? Yes, you can do it by using the encapsulation property. Okay, so within encapsulation property, as I told you, you will be restricting the access of those particular properties which you feel that they should be untouched. Okay, so how are we going to do it? We are going to do it by using the local and protected keywords. Now, I hope you got what is the encapsulation means, what is the need for encapsulation, and what is actually the encapsulation. Now many of you are getting confused between local and protected keywords. Okay, for this I'll give you a small example so that it will be easily understood for you. Okay, we have like before we have taken a student's data example, right? There we have talked about library, is it or not? So taking the same library as an example for our encapsulation property, let us consider, okay, library will be having so many books, is it or not? So among these books there will be some books which you can take with you, like for particular, okay, let us consider you are in a college. Okay, there will be some books which you can take home, or which you can take with you for a period of some 10 to 15 days. Okay, that is also limited, you can't take it forever, but it is, you can take it with you for 10 to 15 days. And there will be some books which you can't take, you should read only in that particular library itself. You are not allowed to take those books with you. Okay, so those are some books which you could take with you, and those there are will be some books which you couldn't take with you. Now coming to this, the books which you could take with you to your home for 10 to 15 days, this is called a protected keyword. That means by using protected keyword, you could handle the properties and methods of base class in child classes also. Okay, so with protected keyword you can use the properties of base class in child classes also. You can access the properties of base class in child classes also. Just like you can take books, but that is limited to 10 to 15 days. Similarly, you can use the properties of base class in child class only. But after child class, because after child classes you will be having some modules and all. Okay, again within this module you couldn't use this particular properties. Just like after 15 days you should return it at any cost, right? Similarly, after child class you couldn't use this particular protected properties outside the child class. Now coming to books that you couldn't take at least with you, that means you should use only those books within the library itself. So that is nothing but local keyword. So in this local keyword, the restriction is lot more compared to that of protected, because in protected at least you could use the properties of base class and child class, but in local there is no such case. If you are mentioning the base class as local property, if you are mentioning that property as local, then that means you could use that property only in base class. You couldn't go out of the base class. That means you couldn't use that even in its child class. You could use only that property in the base class. Just like that books you couldn't take outside the library, similarly you couldn't use these properties outside the base class. You should use these properties within the base class itself. That is called local. Clear? Okay, hope you got an idea on what is this local and protected keyword also, right? So this is about the four important properties in OOPS. Hope you got an idea on what are all these properties in clear, like a clear cut idea on these properties. And also, but along with this, try to check out the properties with examples clearly, because even though I have given you an idea on these properties, but when you try to check out the examples, and when you try to gather the information based on the codes, so that it will be more useful for you, because whenever you enter into interviews or something, you will be asked to write the codes, or you will be asked to estimate the code output. Okay, they just don't ask you the definition of this particular thing. Okay, but I made this video so that it will be helpful for you to understand, that to grab the concept of these four things, right? So this is about today's video. If you like this video, please do give me a like. It is kind of motivation for me to do further videos on such concepts. That is all for today. Thank you all.